Hi everyone, so here we are in Process Slicer and we've got this Benchy model loaded up and we've also configured it so that it's colored nicely. The great thing about Process Slicer is that with multi-material parts you have all of the features here on the right that you can then decide which color to fill if the model is designed for multi-material printing. If not, there's always the paintbrush option here for manually um, coloring your models. So we've got this Benchy here again because it's a great model to print and it's got a ton of features on here that test the printer's ability to do things like overhangs and bridges and finer detail as well. So let's go through the settings and take a look at what we're printing with. So at the layer height, we've set to 0.2 millimeters. We've got 3 perimeters and 4 top and bottom layers, 4 top and bottom solid layers. The infill we've set to 20%, and for our speed settings, we're printing perimeters at 150 millimeters per second, small perimeters at 45 millimeters per second, and external perimeters are 75% of the 150 millimeters per second for all other perimeters. Infill's at 150, solid infill 130, top solid infill at 110, support materials 45, bridges 75, and gap fill at 50. Travel we've got set to 300 millimeters per second, and our acceleration values are 10k for infill, 12k for travel, and 6k for everything else. Of course, the printer can be pushed much further than this. These are like our default print settings. So these are the settings that um, we would use in most cases just to guarantee reliability and quality. But of course, depending on your model, depending on what you're printing, you can, of course, push these values um, higher because the machine will be able to support it. And over in filament, we've got PLA printing at 190 degrees Celsius. And of course the heated bed as well, set to 60. Um, and then in printer settings, of course, we've got our 3 extruders, our 3 printheads, because this is a tool changer machine. And the advantage of that is we can set settings like nozzle size and retraction settings for individual printheads, depending on what we're printing with them. So those settings can just be found over here. And then in the physical printer tab, we've got our main sail interface, and this interface is really nice. It's really nice that we've got access to it here in Process Slicer as well um, for controlling your printer. So if we go back to our platter, where we've got our Benchy model loaded up, we can hit slice now, and it will slice the model and we can upload it straight to the printer right from here by hitting this button, and it will upload the model straight to the printer. Okay, let's head over to the printer and get printing. So while we're here, I also want to touch upon the fact that we're not printing with any sort of purge tower or priming tower. Typically, when you print with multiple materials using a multiplexer of some sort, you have to purge the nozzle first for previous color and previous filament, and then bring in the new filament. And that wastes a lot of material and a lot of time as well. So this is like one of the big advantages of using a tool changer printer for doing multi-material printing is that you don't need any sort of purge tower. So there is, however, a wipe tower that you can enable if you wanted to. It would add a little bit of time and use a little bit of extra material as well. But our goal is to print without it. And we're able to do that by carefully controlling retraction settings and also making sure that when the printer is docked, there isn't any oozing happening. And also with our docking bracket, there is also a wiping area where if any material were to ooze out of the nozzle, it's wiped off there before coming over to our print. So here we are at the printer, and before starting the print, we're going to run through the calibration process. So this process isn't something that you need to do each time you start a new print, but we're going to do it now just to show you how it works. So what we'll do first is move the flex plate forward like so, and then we'll take the probe like so, and we'll be mounting it to the back of the platform like this, and we can just tighten down this bolt with an Allen key until the probe is secure, and then we just take the cable from the back of the platform and plug it in to the side of the probe like so, and then move the flex plate up against to the edge of the probe. So there we are. Now we're ready to start the probing process. So what we've done here is, before starting, is heat up each of the print heads to 200 degrees Celsius. The calibration process does this automatically as well, but we've done this preemptively and also wiped the tip of the nozzles, so just to make sure that there isn't any filament on there, and that's something you want to make sure to do before starting the calibration process. So calibrating is really easy. We go down to the touchscreen here, and what we'll do before starting is just home the printer. Do that like so. So just give it a minute to let it home. So now it's homed, we'll go back down to the touchscreen and start the auto-calibration process. Go into macros and hit calibrate tool offsets, and that should start the process. There we are. And it will take a few minutes to run through this, and once it's done it will save those offset values into the printer's firmware, ready for them to be used for printing. So there we are. So that's essentially the entire calibration process from start to finish, and there the printer now is just restarting. So those calibration values now have all been saved into the firmware. So now we can go ahead and remove the probe and get ready to start a print. So what the printer will do now is home itself. And after it's homed itself, it will ask us to make sure that there isn't any printhead selected. There isn't. If there was, then we can dock that printhead using the interface. As there's not, we can then just hit resume, hit resume like so, and the printer will carry on. What it will do next is probe 3 points on the platform, and it will adjust the platform to be parallel with the gantry. So it's just done that now, and it will start the print by selecting the first printhead.
So it's a little tricky to see the first layer going down as it is a black filament, but it is going down quite nicely. Let's see if I can get a better angle of it. So we've got the enclosure roof mounted on here to give you a look of how the cables and the cooling hose perform inside that enclosure roof. As you can see, everything is really nicely contained there. We are printing PLA, so we've removed the front doors just to give you a better look inside. Of course, if you were printing ABS, you'll want to have everything nicely enclosed to get that good print quality. So even despite having that extra bulk on the print head, as it is a tool changer, we are still able to print very quickly here, and that's partly due to the 4 motors on the gantry enabling us to hit those higher speeds and also be able to do that reliably. So we'll come back later once it starts printing with the other print heads. So here, without the use of any sort of purging or priming, we're able to rapidly switch between printheads, which means that 99% of the time we are printing, and this is probably the most efficient way of doing multi-material 3D printing, as you're wasting zero time and zero material. A tool change takes only a few seconds, and you can see just how reliable our system is and the detail that we're able to capture on this benchy with those very small features as well being able to be printed. So here we have the print now completed, and we'll take a look at the quality of it. And there is some stringing there, but not a major amount. And also, even though we're printing without any sort of priming tower or purging tower, you can see that with careful retraction control and with our docking brackets, we're able to get zero cross-contamination and ultimately print multi-material in the quickest and most efficient way possible.